See Standard 12th Maths Chapter 5 Exercise 5.2 Question number 6 and 7. Sixth sum. Prove that the length of the lattice rectum of the hyperbola x square by a square minus y square by b square equal to 1 is 2b square by a. First let us have the hyperbola curve. See hyperbola x-axis and y dash. This is the center of the hyperbola, and the two foci of this hyperbola is AE, 0, and this side you will get S dash is minus AE, 0. Okay, look at the first statement. The length of the lattice rectum. So what is lattice rectum actually? It is a line segment passing through this focus. It is a line segment passing through this focus, and it touches the hyperbola curve at the point L and L dash. L and L dash. So we have to find the length of this lattice rectum, L and L dash. So you have to find this. So for this, first you find the coordinate of this L and L dash. So the x coordinate is, as it passes through the point AE, 0, its x coordinate is same AE, but we don't know what is y. And here again it is AE, but you have to find the y value. Y value is negative this side because it is below the x-axis. So first let me find those coordinates. Since these 2 points on the curve hyperbola, it satisfies this equation. Take one point L as AE, y. So hyperbola equation x square by a square minus y square by b squared is equal to 1. It satisfies this equation. Replace x as AE, that is x squared, a squared e squared by a square minus y square by b squared is equal to 1. A squared gets cancelled. So e squared minus y squared by b squared is equal to 1. So you take this y square b square to the other side, so it becomes plus. Bring this 1 to the left side, so minus 1. What is the value of this e in the hyperbola? So root of 1 plus b square by a squared. So e squared is, the root will get cancelled, 1 plus b square by a square. We need e square minus 1. So e square minus 1 equal to 1 plus e squared is 1 plus b square by a square minus 1. Plus 1 and minus 1 gets cancelled. You will get b square by a squared. So replace here b squared by a squared. This is equal to y squared by b squared. Bring this b squared to this side. So b squared into b squared by a square is equal to y square. What is the value of y here? So square root of b squared into b square, b power 4 by a square. So square root, that is plus or minus b squared, half of this. Then a squared is a plus or minus b square by a. So the y coordinate of this lattice rectum here is AE, plus b square by a, and here the negative side AE, minus b square by a. So take these two coordinates. L is AE, b square by a, and L dash is AE, minus b square by a. So what is the question here? You have to find this length of the segment L dash. So that is the distance between these 2 points. So L dash is equal to square root of x2 minus x1, that is AE minus AE the whole square, y2 minus y1 b square by a minus, here minus, plus b square by a the whole square. So this is 0, square root of 2 times b square by a the whole square. So square root and square will get cancelled. 2 into b squared by a. So therefore the length of the the length of the latus rectum LL dash is equal to 2b square by a. This is the answer. See the seventh sum. Show that the absolute value of difference of the focal distances of any point P on the hyperbola is the length of its transverse axis. Now let us have this. See the center of the hyperbola and the two vertices here A dash. This is A comma 0 and minus A comma 0. And this is the directrices x equal to A by E and this is x equal to minus A by E. X axis, Y axis. Now come to the question. The absolute value of the difference of focal distance. What is focal distance of any point P? So let me take a point P, x comma y on the hyperbola. This is S, A, E comma 0 and this is S dash minus A, E comma 0. Focal distance. The absolute value of difference of the focal distances. What is focal distance? The point line joining this arbitrary point with the focus. This SV is one focal distance. Here you will get one more focal distance with the other side S dash. S dash P. The difference between this, that is S dash P minus SP, absolute value, that is modulus value, always it is positive. This is equal to, you have to show the length of the transverse axis. What is the transverse axis here? For this hyperbola, this x-axis is the transverse axis. The length is the distance between A and A dash, two vertices of this hyperbola. So what is the length of this A and A dash? So from origin to A you are getting this A distance and this side 0 origin to A dash is A. So the length of this transverse axis, that is A dash, is equal to 2A. So you have to show this is equal to 2A. This is the question. Prove that. So let me have one more concept here. You draw the perpendicular line to the both of the directrices. Here from P to this perpendicular distance, first directrices is PM and same perpendicular line you extend here, it meets the other directrices at the point M dash. PM is one perpendicular distance and PM dash is the other perpendicular distance. Just you keep this one. Okay. So we know the condition for the hyperbola SB by PM is equal to E, where E is greater than 1. The same thing, the other focus S dash P divided by PM dash. So M dash is the perpendicular distance, the perpendicular line drawn, the directrix at the point M dash and also M. This is also same E. So SP is equal to EPM and S dash P is equal to EPM dash. So find the difference S dash P minus SP, that is EPM dash minus EPM. Take E as common. So PM dash minus PM. What is PM dash minus PM? PM dash, P to M dash here and P to M here. If you subtract here, you will get MM dash. E is E into M dash. So find the distance of this MM dash. Actually, this is the distance between the directrices here. See this directrix from the origin to this directrix is the distance A by E, and from the left side again the same distance between the origin to this directrix is A by E. Just take only the magnitude. So AE plus AE, that is 2 times A by E. So E gets cancelled, so you will get 2A. So absolute value, it is positive only. S dash P minus SP is equal to 2A. That is length of the transverse axis. Thank you.